In this video, we want to talk about how to find the derivative of an implicit function. Now, before we dive into this topic, there are some few tips I want to share with you guys. Let's say we have a function that says y equals fx. This simply means that y is a function of x. Y changes as x changes. X is the independent variable. Y is the dependent variable. Now, if I should tell you that fx equals 2x plus 3, since y is a function of x, instead of calling this function here, instead of using fx, I can also say that y equals 2x plus 3. So what I'm trying to say here is that if I can use fx for this function here, I can also use y for the same function because y is a function of x. So let's keep that in mind. So if we are given this function here, remember that they are the same function, and we are told to find the derivative of this function. In my previous video, I've been using the word f prime x to find the derivative of any function. In addition to this notation here, we can also use the notation, the y, the x, when finding the derivative of a function. We can also use y prime. We can also use f little x. All of these notations right here are the same when trying to differentiate a function. In other words, these notations are the same when trying to find the derivative of a function. You can either use f prime x, or use the y dx, or use y prime, or use f sub x. So I want you to keep this in mind, just in case you are given any function to differentiate. Now, let's dive into the main topic. So for the topic implicit function, let's say we are given a function. Let us pick up a question that we find interesting. So let's say we have a function that says three x plus y equals 3. Now, if we are given this kind of a function and we are told to find the derivative of this function, If we look at the functions we've been differentiating in the past video, you will realize that we've been dealing with x. We've been differentiating with respect to x. But looking at this function here, you will realize that another alphabet is being introduced, which is y. So in this case, since y has been introduced to this function, it is known as an implicit function. Every other functions we've been differentiating in the past video is known as explicit function. So the difference between explicit function and implicit function is that explicit function has to do with one variable, which is x. But the implicit function is the mixture of two variables, which can be x and any other variable. This time we have y. So how can we find the derivative of this function? Now, our main goal in this case is to isolate the y dx. So let's go. If we are told to find the derivative of this function, how can we do it? So first things first, we have 3x here. The derivative of 3x is 3. Then we break the plus sign down. So the derivative of y is what? Keep in mind that anytime you are differentiating y under implicit function, you will always introduce the y, the x. So the derivative of y under implicit function is the y dx equals the derivative of a constant is 0. So let us isolate the y dx. So to isolate the y dx, we need to subtract 3 from both sides. So we have 3 minus 3 plus the y, the x equals -3. So this becomes 0. And at the end of it all, we have the y, the x equals -3. And this is our final answer for this problem. So let's move further. Let's say we have a question that looks like this. X cubed plus y cubed equals 3xy. Now, let us solve one. The derivative of x cubed is 3x squared. Now, the derivative of y cubed is 3y squared. Don't forget, we need to add the y dx to it. The y, the x. Anytime you are differentiating y, we need to add the y dx to it, which is equal to. Now, if we look at the expressions we have after the equality sign to the right-hand side, we have 3xy. For simplicity, let us separate the constant 3 from the variables xy. Now, we have x and we have y. Keep in mind that x and y is product rule. And in my previous video, I gave you the formula for product rule as f prime x equals f prime x gx plus g prime x fx. Alternatively, we can find the derivative of a function using product rule by introducing the y, the x. So at this point in time, if we are given two functions, it's either we call it fx and gx, or we can call it u and v. So if you call your functions u and v, you can use this formula to differentiate your function using product rule by saying u, the v, the x, plus v, the u, the x. These two formulas right here are the formulas you can use in differentiating a function. These are product rule. So for if you don't understand product rule, I will advise that you check my previous video so you have a better understanding of how to differentiate a function using product rule. The only equation I did not introduce in my previous video is this. So for the sake of this video right here, I will use this equation here, but the both of them are product rule. So we can use either, but for the sake of this video, I will use this. So let's keep things going. If I am to use the second formula for product rule, which involves u and v, in this case, I will call x u. That means u equals x and v equals y. So let us introduce it to the right-hand side. So we have u dv dx. Since our x is equals to u, then we have our x here. Dv dx, that means we are differentiating y. And anytime we are differentiating y, just include the y, the x, plus v is y. The u, the x. In other words, what is the differentiation of x? The differentiation of x is nothing but 1. So at this point, let's solve further. We can see this as 3x squared plus 3y squared, the y, the x, equals, we open the parentheses, so we have 3x, the y, the x, plus 3y. So our aim is to isolate the y, the x. So we can do so by collecting like terms first. So we have 3y squared the y, the x, minus 3x, the y, the x, equals, I think there's a shift in here. Equals 3y minus 3x squared. We go further by saying we can factorize both sides. So we have 3, the y, the x, open parenthesis, y squared minus x close parenthesis equals 3, open parenthesis, y minus x squared. Then we close parenthesis. So there are some things we can cancel out here. 3 cancels 3. So we would like to isolate the y dx by dividing both sides by this expression here. Y squared minus x. So this cancels this. So we are left with the y, the x, equals y minus x squared over y squared minus x. And this is the final answer for this problem. So let's do some cleanup here and move to the next question. So we have question 3. Let's say we have a function that says x squared plus 3xy equals 7y. So the derivative of x squared is 2x plus we have 3 here for simplicity. So of course we have product rule. If u equals x, then v equals y. So we can have our formula here, which is the y, the x equals u, the v, the x plus v, the u, the x. What is u? Of course, u equals x. So what is dv dx? The v dx, it's not the v dx actually, it's dv dy. So we have the v dy is equal to the y dx. So the differentiation of y when we are talking about implicit function again is nothing but the y dx. Plus we have v is y. So what is du dx? Du dx, of course, is 1. There's a notation here. I want to call your mind back to this expression here. This is dv dy. Dv dy is equals to the y dx. So when I say dv dy, I'm talking about the differentiation of y. So of course we have dy dx. And like I said earlier, please, whenever you are differentiating y, always add dy dx. It's very important. So in this case, we open parentheses. And of course, we have our final answer here to be x, the y, the x plus y. So let's bring this here into this function here. So we have x, the y, the x plus y, close parenthesis, equals the derivative of 7y is 7 the y, the x. So let me create some space here. And as we have it, we can go further by saying 2x plus 3x the y, the x plus 3y equals 7 the y, the x. And of course, we will isolate the y, the x. So we can say that 3x the y, the x minus 7 the y, the x equals 2x minus 3y. And as we step further, we factorize both sides and say, sorry, we factorize the left-hand side to isolate the y dx. So we call this the y dx, open parenthesis, 3x minus 7, close parenthesis, equals 2x minus 3y. Divide both sides by 3x minus 7. This cancels this out. So we are left with the y, the x equals 2x minus 3y over 3x minus 7. And this is our final answer at this point. So let's move further by solving some questions. So let's say we have another problem that looks like this. Y, open parenthesis, x squared plus 1, close parenthesis, equals 7x. So at this point in time, we have a different question. So first things first, let's open the parentheses. So we have x squared y plus y equals 7x. And of course, this is a product rule. So to solve this, we know how to go about it. Let's not forget our product rule formula. So Our formula is nothing but the y, the hex equals u, the v, the hex plus v, the u, the hex. And of course, we have u to be equal to x squared, v to be equals to y. So at this point in time, our u is x squared. So dv dx at this point is our dv the y. So dv the y, which is the same as the differentiation of y, is the y, the x, plus v is y. The derivative of x squared, which is the same as du dx, is nothing but 2x. So at the end of it all, we have x squared, the y, the x, plus 2xy. So let's put these into this position here. So we have x squared, the y, the x, plus 2xy, plus, what is the derivative of y? Of course, it is the y, the x, equals, what is the derivative of 7x? It's nothing but 7. And we want to isolate the y dx. So we have x squared, the y, the x, plus the y, the x, equals 7 minus 2xy. So the y, the x, open parenthesis, x squared plus 1, close parenthesis, equals 7 minus 2xy. We divide both sides by x squared plus 1 to isolate dx, dy dx, x squared plus 1. So this cancels this out. At the end of it all, we have the y, the x, equals 7 minus 2xy over x squared plus 1. And that is our final answer for that problem. So let me solve the last problem, the last but not the least. So let's go with a problem that looks like this. If we have x squared plus y squared minus x minus y equals 2. This is an implicit function. How can we find the derivative of this implicit function? So the derivative of x squared is 2x plus the derivative of y squared is 2y, the y, the x, minus the derivative of x is 1 minus the derivative of y is the y, the x. The derivative of 2 is 0. So let's isolate the y, the x. So we have 2y, the y, the x minus the y, the x equals negative 2x plus 1. And we have the y, the x, open parentheses, 2y minus 1, close parentheses, equals negative 2x plus 1. 2y minus y, 2y minus 1. Then we have some things to cancel out. Now, our final answer is the y, the x equals negative 2x plus 1 over 2y minus 1. And there we have it. That is our final answer right there. And at this point, I would like to give out some exercise for you to do during your free time. So number one, we have y. There's a shift in here. We have y equals 6x plus 5. The second problem says y squared equals 12x squared plus 3. Number 3, we have x squared plus y squared equals 14. We have x cubed plus y cubed equals xy. The fifth, which is the last one. So we need to have 4xy equals y plus x. So that is it for this video. Thank you so much for watching. Have a great day.